Hello, I'm going to go through this log question that I gave you the other day and hopefully make a little bit more sense of questions like this. Now on the first one, we've got log to base x of 324 equals 4. Now what I was impressed to see is most of you could switch it into exponential form, which is exactly what we want to do with this log. So here we'd say x to the power of 4 equals 324. And then what I would do is, because I want to find what x is, I would find the fourth root of both sides, which I believe most of you did here. The problem is, when you do this on your calculator, it's not going to give you an exact answer, and that's what we're looking for here. We're looking for our answer as a simplified surd. And that's because your calculator can't deal with things like the fourth root typically. Now, when we're finding the fourth root, another way of thinking about that is we're square rooting and we're square rooting again. And basically, your calculator's doing one too many operations there to give you as the exact value. So what we're going to do is we're going to square root both sides. Okay, when we square root the left hand side, we get x squared. When we square root the right hand side, we get 18. So now we can just square root both sides again, and then we'll get x equals the square root of 18. We want it as a simplified surd, and now your calculator should give you it as a simplified surd, but just in case, how we'd do that is we can split up square root of 18 into the square root of 9 times the square root of 2. So that would just be 3 root 2, which is going to be our answer. Then on to part 2, so a little bit more work to do here for these 5 marks. But the key with questions like this is we want to get all the logs onto one side, all the non-logs onto the other side. And then on the side that we have all the logs, we want to combine it all into one single logarithm. Okay. Sometimes there might be other strategies you can use, but generally that is a strategy that works with the majority of these questions. Get all your logs onto one side and then combine it into one single log, and then, just like we saw at the start, we can switch it into exponential mode. So here we've already got the logs onto one side, but what we want to do is we want to combine these two logs into one single one. And to do that, we want to make use of the rule, as long as we've got the same base here, that log x take away log y, sorry about that, log x take away log y equals log x over y. Okay, so it's taking these two logs and combining it into one single log using that second law of logarithms with the subtraction. So here, this left-hand side, log 5y minus 4 log 2 minus log 2y, I can combine that into 5y minus 4 over 2y. And that will just equal 3. I can use that as long as I'm working in the same base. So now, just like I did in the first part, I can switch this into exponential form. So this now becomes a to the power of 3 equals 5y minus 4 over 2y. Okay, so it's a really powerful tool, switching it from log form to exponential form, really important that you learn that. So then all we need to do with this a cubed equals 5y minus 4 over 2y, what I now want to do is just simply write this in the form y equals. So basically I'm just making y the subject. So I'm just going to rewrite it over here to make it nice and clear. And all we need to do this is get all the y's onto one side, all the non-y's on the other side. So I'm just multiplying here by 2y. So now we haven't got the fraction. I'm going to add 4 to both sides. I'm going to take 2y a cubed from both sides. And now what I'm simply going to do on this right hand side is factorise the y. And now I'm simply just going to divide both sides by 5 minus 2a cubed. Now, depending on how you rearrange, you may also have y equals minus 4 over 2a cubed minus 5 as your answer, and that is perfectly valid as well.